Okay, so today we're going to be talking primarily about Bronsted Lowry acids and bases, but we're going to do a quick review of that intro to acids and bases with Arrhenius's model so we can compare them. All right, so just to start off, just to review dissociation of ions, that's when the ions separate out. So for example, HCl, hydrochloric acid, when it's in solution, it'll actually be H plus ion, and it'll be a Cl minus ion. Okay, so that's what it looks like when it dissociates out. It's H plus and Cl minus. And just a reminder that H plus is the same thing as a proton, that positive charged ion. All right, so Arrhenius. Arrhenius was the guy who first defined acids and bases, and he said that acids, they taste sour, and bases, they are a little bit more slippery, but what's the chemistry behind it? And so he basically said that acids had H plus in them, bases had OH minus, okay? So he said acids produced hydrogen ions in solution, so like hydrochloric acid produced H plus, and then it also made Cl minus, and he said bases produced hydroxide, so they produce Na plus, which he doesn't care about, but he does care about the OH minus, okay? So this made it a base, and then this makes this an acid. That's what Arrhenius believed, all right? So something to think about is, what does that make water? When water separates into H plus and OH minus. So is it an acid? Is it a base? What do we call that? All right? So we know that Arrhenius had a great start, but he wasn't the person who created the definition of acid and base that we use today. And this is the reason why. So we basically have something like baking soda separates into Na plus, and it separates into this polyatomic ion, HCO3 minus. Okay? Well, that's not H plus, so it's not an acid. And that's not OH minus, so it can't be a base, according to Arrhenius. So the limiting factor in Arrhenius's model is that not all bases have OH minus. Okay? Not all bases produce OH minus. This one actually produces HCO3 minus. This is actually a weak base. Okay, baking soda is a weak base. All right, so it's actually a little bit basic. All right, so let's learn about what Bronsted and Lowry said. So we've got Bronsted and Lowry, and Johann Bronsted was Danish, and Martin Lowry was English, and they were working in different places, and they came up with the same idea. And what they said was that acids and bases definitions should be about the movement of the proton, the movement of the H plus. Okay, so it's all based on the movement of the hydrogen ions. So defined by the movement of hydrogen ions, or the proton, which is H plus. Okay? They said that acids are proton donors. They donate the proton. Okay? So they give away protons. Bases accept the proton. Okay? So a proton travels from the acid to the base. Okay? One more time. Proton travels from the acid to the base. So let's look at that. All right? So if you look at this equation, what you should be able to notice is, if you look at the reactants, you've got HCl and you've got H2O, and then it produces H3O plus and Cl minus. So what's actually happening is this H is traveling from here to here, okay? And what you'll notice, so this donates the proton, so it's the acid, so we're going to label that. Well, once it's donated the proton, we have a name for it. This is called the conjugate base. So the chlorine that's left over is called the conjugate base, okay? And then this, the water, acts as the base. And then once it accepts the proton, it becomes more positive. We call that the conjugate acid, all right? And we're going to learn how to label each of these in a few moments. So, what is our conjugate? Remember, a conjugate acid is something that is going to be gaining a proton. So the conjugate acid gains a proton. Okay, so let's add a H plus here. So we've got NH, not 3, but 4. And the charge is now going to change to plus. So the conjugate acid for NH3 is NH4 plus. All right. The conjugate base is what end up losing an electron. Sorry, not losing an electron, loses a proton. All right, so here we're going to take this H and move it away, take it off. So NO3 is left over, and when you take away the H, you take away its positive charge. So now we go from neutral to a negative charge. So this becomes more negative. All right. And then the conjugate acid up here becomes more positive. Right? So that's your conjugate acid and your conjugate base. So here we're going to do an example together about how to identify the acid, the base, the conjugate acid, and the conjugate base. All right? So we're going to start by circling the proton, and we're going to show its movement. So if I look right here, I've got HNO3, and I've got NO3 minus. So that's going to be a conjugate acid, so an acid conjugate base pair. All right, they're paired up. So this H is going to move here. So this is going to be the acid, and this is going to be its conjugate base. So those are one pair. All right. This right here, NH3, is going to be gaining the proton, so it's going to be the base, and then it becomes the conjugate acid when it becomes NH4 plus. So it becomes more positive, conjugate acid, all right? So there's a couple of ways that you can strategize doing this. First step should always be circle the proton that moves and then show the path of its movement, okay? The thing that you circled, okay, where you circled the hydrogen is going to be the acid. Where the hydrogen's going is going to be the base, all right? And then from there, you want to look at it, okay, what is paired up with the acid? What's left over when the acid donates the proton? That's going to be your conjugate base. And what happens when the base accepts that proton? That's going to be your conjugate acid. All right, we're going to do lots of practice with these together. Last thing that I want you to think about, we're going to revisit this. What happens to water? Well, here, the H of the water separates, okay, into OH and H+. Okay? Here, this H moves on to here. So, like, what's going on? An H moves from here and separates. An H can get added. I don't know. All right? This is called amphoteric. Okay? So it basically says that water can act like an acid or like a base, and it depends on what it's in a solution with. Okay, so it depends on what it reacts with, what it's combined with. All right, it can act like an acid sometimes, or it can act like a base sometimes. That's called amphoteric. Amphoteric. And that's all for today. Make sure you guys have those notes in, and we'll be ready to rock and roll. Awesome.